Once again, the solver complains about the load step, especially the SPCs referenced. Let us start the analysis. You may say, I know this error message already. It has to do with constraints. Good. Do you remember the debugging steps? In case you don't feel too familiar with the error message, here is a brief summary. The solver complains about SPCs. As a reminder, constraints are called SPC, single-point constraints. There are at least two places you should go to. First, the load step panel, because of the hint about case control, and second, the model and model browser in order to disable and enable the constraints from the display. This time, we start disabling the constraints and forces from the display. Did you notice anything? Apparently, the constraints are placed in the load collector of the forces. Hence, all we need to do is to move the constraints back into their dedicated load collector. Do you know how to do this? This task can be accomplished by using the organizer. Select the constraints via Shift and left mouse button. Specify the target load collector. Notice that the color of the constraint symbols are now in line with the blue color of the load collector named constraints. As you can see, using different colors for different entities is always helpful. Take advantage of it. This error message, actually it is a warning, is about a load case with 0 forces. After the analysis was completed, the following information was prompted in the window. There are no real complaints about anything. It seems we are done already. Nevertheless, let us review the out file. As it was mentioned earlier, it is always recommended, actually it is almost a must, to review the out file. Note the warning message which says something about 0 forces assigned to load case 1. Despite the fact that the analysis run was completed, something seems to be wrong with the load step definition. My recommended debugging steps are: first, review the load step definition. Check whether the load collectors are referenced properly. Second, pursue a visual check of the model by employing the model browser. Just compare the color of the force and constraint symbols. Also disable and enable constraints and forces from the display. Well, to shorten the debugging steps, I want to draw your attention to the color of the force and constraint symbols. Do you see the problem? The answer to the problem is that, by accident, the forces are stored in the constraints collector. However, I guess by now you know how to solve this issue. This error message tells us that some elements are missing property information. Again, I would check everything related to properties. The error message is quite different than the others we have seen so far. See Quad 4 element number 1633 references a missing property. My 2 recommended debugging steps. First, check the property, and second, check whether the property is assigned to the elements. Let's view the log file first. The analysis log file reports that this kind of error occurs 3 times. As mentioned before, something related to elements and their properties seems to be wrong. Hopefully, you remember the highlighted toggle. In the following slides, we make use of the display option, Show Elements by Property. Note the gray-colored elements. The gray color typically refers to elements without property definition. Based on this understanding, the next steps are rather straightforward. We need to assign a property to these elements. Of course, other options for checking and displaying elements according to their property do exist. This seems to solve our problem. At least all elements are now displayed in line with the color of the property collector. Remember, you may also assign the property to the component collector directly. In this case, you need to select the component collector, and then activate the Assign option. It all depends on your process and preference. This error message provides several hints about likely modeling errors. In the first instance, the length of the error message may be a bit frustrating. Stay calm, as you will see, it isn't that complicated. Surely, we should view the analysis log file, not only due to the length of the error messages. The log file provides several hints regarding likely model errors. Where to start? As indicated, the model may not be sufficiently constrained. In this case we should check the load collector name constraints, and of course, we need to understand whether the applied constraints are reasonable. If we have made a mistake there, it may happen that the model will fly away. This would result in so-called rigid body mechanisms. As the model does not include any gap elements, we should focus on extremely thin shells. Do you remember where the thickness of the elements is defined? The thickness definition is part of the property definition. Hence, let us check the property collector next. Here we see the cause of our error message. The thickness is not specified. Based on this finding, the next step should be straightforward, just assign a value and you are done. We came across the same error message before. Some elements are missing their property definition or an incorrect property is used. Do you remember the debugging steps? In this case, the solver run is aborted as well. The error message says, C quad 4 element number 1138 references a missing property ID 4 or uses property of incorrect type for this element type. The two important keywords are elements and property. This should already point you to the place you need to check. Let's view the analysis log file for some more information. 757 error messages. Should we delete the model and start from scratch? Even though the list of error message is incredibly long, we shouldn't be frustrated. It is the same error over and over again. You may start with displaying elements according to their assigned property, or by checking the property collector in the model browser, as we will do in the next steps. Do you have any ideas as to what is wrong here? Remember, we are dealing with shell elements. The error message is due to the card image, psolid. So, how can we change the card image from psolid to pshell? Close this panel and select the property name prop shells, and activate the option, Edit. Again, we see that the currently assigned card image is psolid. This needs to be changed to pshell as we are dealing with shell elements. Remember, we only specified the card image pshell. Nothing more. We still need to say something about the thickness of the element. Just click on T, in order to assign the required thickness value. Then you are done. This concludes our video on error solving.